Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this is the second video for the second chapter, that is single phase transformer EPO244. So during our previous lecture, that is the first part of transformer, we have already learned on how to get the parameters of the approximate equivalent circuit of a transformer, whether it's referred to primary or referred to secondary equivalent circuit. So we have learned on how to get RCP, XMP, R equivalent P, S equivalent P, and also for secondary. So now that we already have the approximate equivalent circuit, so next step is what we're going to do with the equivalent circuit. Okay, that is what we're going to do today. Okay, so the next part is, if we already have the equivalent circuit of the approximate equivalent circuit of the transformer, we can examine the performance by finding the number one, voltage regulation, and number two, the efficiency. There are two parameters. So voltage regulation, if it's low, then it's better or good lah. But for efficiency, the higher your efficiency is, the better the performance of a transformer. So first we go to voltage regulation. So what is voltage regulation? So actually it is a quantity that compares the output voltage, okay, that is your secondary voltage lah, because your output is on secondary side. Quantity that compares the output voltage or the secondary voltage of the transformer at no load with the output voltage or the secondary voltage at full load. Okay, so it is a good practice to have a small voltage regulation. So means we don't want to have big difference between no load and full load secondary voltage. So the formula, okay, for ideal transformer where there is no loss, the VR should be 0, okay. But for real transformer, this equation here is how you calculate the VR. Okay, so Vs or V secondary, first of all, please notice that all the voltage used here is on the secondary side. Why? Because we compare at the output. So output for transformer is on secondary. So Vs no load minus Vs full load over Vs full load. So as I've mentioned before, full load is also known as rated. Okay, so Vs full load equal to Vs rated. That is the secondary voltage when the transformer is supplying maximum current. Okay, so Vs no load is the secondary voltage when the transformer is not connected to any load. Okay, so okay, it's stated here. Wait. Okay, there are certain things you need to know about full load or rated condition. So basically the formula for secondary rated current, okay, equals to rated S or rated parent power divided by rated secondary voltage at the angle of plus minus cos inverse perfected, and that plus minus depends on whether it's lagging or leading. If your transformer is operating at lagging power factor, so the angle of current should be negative, and vice versa. Okay, so you should know that at full load or at rated condition, transformer is supply maximum or 100% of rated secondary current, IS rated yang atas, from the first formula, from the above formula. Okay, again, at full load, transformer is supplying maximum or 100% of IS rated it can supply. So we can say that your N is 100% or 0.1. At half load, transformer is supplying only 50% of IS rated that it can supply. So now your N becomes 50% or 0.5. Okay, and then at N load means at any percentage of load. For example, at 75% of rated load, transformer is supplying 75% of rated secondary current it can supply. So in that case, your N is 0.5. So where do we use this value N? Okay, we'll look through it shortly after this. Okay, just now the formula for VR is the general formula. Vs no load minus Vs full load over Vs full load times 100. But since we are having two different approximate equivalent circuit, that is number 1 referred to primary and number 2 referred to secondary. Therefore, we will have two different sets of equations to calculate voltage regulation. Okay. First, okay, let me start with referred to primary first. But before that, please take note IS equal to S over Vs or S rated over Vs rated at angle of plus minus cos inverse power factor. Now, the formula for VR for referred to primary is equal to Vp minus AVS full load or AVS rated over AVS rated. So from where do we have this formula? Okay, the general formula is Vs no load minus Vs rated over Vs rated. So Vs no load for referred to primary is the front one. When we don't have any load here, so no current will flow through the load. So voltage here equals to Vp. That's why Vs no load equals to Vp. While Vs full load, just simply take the secondary voltage, the voltage across the secondary part, that is AVS. In other words, it's easier if we can conclude that the formula for VR is front minus back divided by back. Okay, Vp minus AVS full load divided by AVS full load. But bear in mind, because it is not stated here full load, and we know that it's a no load secondary voltage, so we cannot simply take the value of Vp rated from the question. Instead, we have to calculate it by using KVL. See, Vp you have to calculate using this KVL. So from where do we have this KVL? Just write down KVL equation around the large loop here. Okay, so Vp equals to, okay, we have here two impedance, R equivalent P plus X equivalent Pj times the current that flows through it, that is Is over A, okay, plus AVS. Okay, so that Is 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 rated, and the Vs used here is Vs rated. But notice that in this KVL equation, there is the term N here in front of the Is rated. Because why? Okay, your transformer can be operating at any condition. If it's operating at full load, then your N is, oh, this is wrong. This should be 1. My mistake. N equals to 100% or equal to 1. Okay, so never mind. If it's operating at full load, so N equal to 1. so it has no effect. But if your, for example, your transformer is operating at 75%, so your N now become 0.75. In other words, at that point, at that stage, only 75% of your IS rated calculated from this formula is supplied to your load. So in the KVL, you need to insert the N, right? Okay, so same goes for referred to secondary. So just like I said just now, same explanation. So it's easier if we memorize it as front minus back divided by back, right? So for referred to secondary, if you are using all the values from the referred to secondary approximate equivalent circuit, so the formula for VR is VP over A minus VS full load divided by VS full load, front minus back divided by back. So in this case, your KVL equation is VP over A. Okay, from where do we get this value of VP over A? From KVL also. But KVL around this referred to secondary equation, that is IS, okay, times R equivalent S plus X equivalent SJ, and then plus with VS. So IS rated and VS rated, and again we have N in front of your IS. Okay. So how do we apply this? So let's refer to our example. So this is actually before this, in example 1 Roman, we have solved part 1 here, where we have already sketched the approximate equivalent circuit referred to high voltage side, that is referred to primary. So that is the equivalent circuit with the values of RCP, XMP, R equivalent P, S equivalent P. So number 2, calculate the voltage regulation at 0.866 lagging power factor. So now, since we only have referred to primary, oh, before that I forgot to mention, if your friend, if student A is using referred to primary approximate equivalent circuit along with the equation, while student B is using referred to secondary approximate equivalent circuit along with the equation, the final answer for VR for student A and student B will be and should be the same. Okay, so in other words, I can say that you can choose whether to use referred to primary or referred to secondary if you have both of them. But if you have one of them, yeah, just use whatever. For example, this example we only have referred to primary, right? So just use the referred to primary circuit and the corresponding formula. Okay. Alright. So the formula for VR for referred to primary is, remember, front minus back divided by back. So that is VP minus AVS over AVS. So A is already being calculated in when we answered number 1 Roman. That is 5, yeah, 5. Sorry about that. This should be 11.05K minus 5 times 2.2K. Okay. So now the question is, what is your VP? You have to find your VP according to the KVL. So now your KVL is, okay, IS over A times N, okay, times R equivalent P plus JX equivalent P J plus AVS. So in this case, your n is stated in the third question, that is 75%. So have to multiply 0.75 in front of IS rated. Okay, so R equivalent P, just take whatever you have calculated before, 3.255 plus your A times VS rated from your equation 2.2K. So you get that. Okay, notice that VP no load, VS no load, that is VP in this case, is 11.05, and it's not the same as the VP rated. Okay, so that's why you have to calculate. You cannot simply take from the question. Yeah, and then so now you can before that, to find IS rated equal to S rated from the question, 100 kVA divided by VS rated 2.2K at angle of minus. Why minus? Because lagging. Cos inverse power factor given as 0.88, so that is your IS. So just substitute into this KVL equation, and then lastly substitute into VR equation. 11.05 minus 5 times 2.2K divided by 5 times 2.2K times 100. So your VR is 0.45%. That indicates your full load and no load output voltage differs by 0.55%. So notice the value is small, less than 1%. That is good. Okay. So I'll stop for now. So I'll continue in the third part of chapter 2, transformer. Okay, thank you.